Hi everyone, I am Anusha T.J. Today I am going to present our project topic, that is assistive device for blind, deaf and dumb people under the guidance of Sharana Basavaraj based Department of ECE Ballari. Now let us move on to the contents. It includes abstract, introduction, literature survey, objectives, problem statement, hardware and software components, block diagrams, implementation, conclusion, references. Now let us move on to the next topic, abstract. First of all, what do you mean by assistive device? It is nothing but it is a huge part for deaf, dumb and blind for individual life. New advancements are literally changing lives and the way people communication with each other. And we work all about this in the paper. And the paper provides a way for the people with hearing impairment to visualize or read, which is in audio form by speech to text conversion technique, and also provides a way for the vocally impaired to represent their voice by aid of text to voice conversion technique, and also the deaf people can able to hear others speech from text, and all these activities are coordinated with the use of Raspberry Pi. Let us discuss all these activities in the coming slides. Let us move on to introduction. Approximately 285 million people are judged to be visually impaired worldwide, in which 39 million people are blind and 246 people have low vision. So, India is considered to be the home for world's largest act of blind people. In this world, about 37 million people are blind, in which 15 million are from India. So, to facilitate these people, we have developed the assistive device for blind, deaf and dumb people who do not want the assistance of other neighbor. And the development of our project will discuss in the coming slides. Let us move on to literature survey. By R. Suganya and T. Meera Devi has developed design of communication aid for physically challenged people in the year 2015, and they have addressed the problem is communication is a process of conveying an information, feelings, thoughts and ideas with others in the form of verbal or non-verbal. So, disabled people like deaf, dumb and blind are far for communication because of lack of amenities. Deaf, dumb people communicate by the usage of sign language but blind cannot. So, to overcome these for disabled, to communicate here develops a communication aid for disabled people which helps them easily. Let us move on to the objectives. I have given a broader review. In the goal of this project is to provide a standard lifestyle for deaf, dumb and blind people. Through this device, the visually impaired people can able to understand words easily, and the vocally impaired people can communicate their message through text and gestures. The deaf people can able to understand other speech from text that is displayed. This helps them to experience the independent life. Let us move on to problem statement. One of the most precious gifts to a human being is ability to see, listen, speak and respond according to the situations. But there are some unfortunate ones who are deprived of this. Communication between deaf, dumb and normal persons have been always a challenging task. So, the project is very important for visually impaired, blind, deaf and dumb people who cannot read, and the content written in the paper, and this system helps for people to read, to see, to hear. Let us move on to hardware and software components. Hardware components include Raspberry Pi 3, Logitech camera, headphones, SD card. Software components include Raspbian OS, Terazact OS, OpenCV, eSpeak, Python software. What do you mean by Raspberry Pi 3? It is nothing but Pi is a credit card sized computer that connects to a computer monitor or TV and uses input devices like keyboard and mouse. It is capable to perform applications like military, surveillance camera, surfing internet, live games, and some of the devices. What do you mean by Logitech camera? It is nothing but it is a plug and play setup which is easy to apply. We can apply easily for making videos, calls, and major IMS. It is a 5MP camera with high resolution. We are using Logitech camera which is capturing the image and gesture control functions. Everyone knows about headphones. What is SD card? The Raspberry Pi does not have any onboard storage available. The OS is loaded on SD card which is inserted on SD slot on Raspberry Pi, and the OS can be loaded on card using card reader. Let us discuss about software components. What is Raspbian OS? Raspbian OS is nothing but this provides significantly faster performance for applications that make heavy use. And Tesseract OCI is nothing but it is an optical recognition character or optical character recognition engine for various operating systems. This algorithm is able to accurately decipher and extract text from variety of sources, and as per its namesake, it uses an updated version of Tesseract open source OCR tool. Not only we able to extract English languages but also it supports over 100 languages. What is OpenCV? It is a tool and it is a library functions mainly aimed at real-time computer vision. It is developed by Intel Research Center. eSpeak is nothing but it is an open source software speech synthesizer. It is going to compact multi-language open source speech synthesizer, and it uses vowel and consonants, and it going to create a format. Everyone know about software that is called Python. Now let's move on to the next topic, that is block diagram. In the block diagram we can see a microphone, speaker, SD card, and the Raspberry Pi, camera module, monitor. And what do you mean by CSI? CSI is nothing but it is a camera connector for serial interface designed by MIPI. MIPI is nothing but Mobile Industry Processor Interface, aimed at digital cameras with mobile processor. HDMI 1080p is nothing but 1080 pixels of high definition multimedia interface, and the speaker which gives an output for this system, and we uses monitor as well as a microphone. What do you mean by GPIO? GPIO is nothing but general purpose input output. It is a generic pin on an integrated circuit where behavior including whether it is an input or output pin. It can be controlled by user at runtime. GPIO pins have no special purpose defined. Let us move on to these three case diagrams. It includes text to voice, image or gesture to voice, voice to text. Let us discuss one by one. Text to voice, and it shows that the user can write words in a file. He or she uploads a file that is giving as input to the system. System converts words into voice output, and the user can pause or stop or rewind this voice, or he can even listen to the voice as shown in the figure. See, the user can write words and he can upload files containing words, and it given to the voice output, and he or she can re-listen or pause or stop or rewind the speech. Next, image or gesture to speech. It includes user captures the image or gesture from the Logitech camera. he or she can zoom in or zoom out in the image. This is given as input and the voice output is given. One can stop or pause and rewind the speech or re-listen the speech. Next, voice to text. Voice to text is nothing but user can gives the input through a microphone and it verifies voice perfection to the system, and the system gives text output to the user and the text will print on the system. System is nothing but Raspberry Pi. Let us move on to implementation. The project is divided into 4 different modules: text to voice, image to voice using camera, gesture to voice, speech to text. Let us discuss one by one different modules. The first, text to voice. The first process is text to voice conversion is done for dumb masses who cannot speak. They convert their thoughts by text, which could be transferred to a voice signal, and the converted voice signal is sent over the speaker. Speaker is nothing but e-speaker synthesizer, and the keyboard is interfaced to Raspberry Pi, and the type data will convert into voice. This is a diagram as shown. Here is a input, text is the input, and the voice what we have generated is an output. The second module is image to voice. The second process is developed for blind people who cannot read normal text. In order to help them, we have interfaced the Logitech camera to capture the image. The picture which is captured is being first converted to text. In this OCR, they apply the adaptive thresholding technique to change the image to binary image, and so they will transfer them into character outlines, and this character outline were converted into speech, and the group of words forms the text, and it has been read out by the e-speak. This is the output what we will get. The third module is gesture to voice. The third process is developed for vocally impaired people who cannot exchange their thoughts to normal people. Dumb people use gesture to communicate with normal people, which are majorly not understandable by normal people. The process starts with capturing image and crops useful portions, and they will convert RGB to grayscale image for better functioning. To blur the cropped image by Gaussian blur function, and it passes to threshold function to get highlighted portion of the image, and it contours between two fingers by convex hull function. We can implement the finger point too. According to number of defects, the text is printed on the display, read out by the speaker. The third module is The fourth module is voice to text. The fourth process is developed for hearing impairment people who cannot understand the words of normal people. In order to help them, a project is provided with a switch which is used to convert voice of normal people text, and we supply for the hard of hearing people who cannot learn the words of others. In parliamentary law, to help them, we have used this assistive device for deaf people. This processor is to receive the voice and convert into text. It uses an online application. Online application is URL Chromium browser. This is a diagram. The remaining part of the project will explain my project Comet Thank you.
Myself Bhavani, I will continue the rest part of the project. These are the 4 different modules used in this project. They are text to voice, image to voice, gesture to voice and voice to text. Module 1, text to voice. Here we have some sequence of steps to be followed so that text is converted into voice format. Step 1, start. Step 2, choose option 1 to convert text to voice. Step 3, call the function text to voice. In step 3, we are calling the function to convert text into voice. Step 4, convert text to voice using speaker synthesizer. In step 4, we are making the use of speaker synthesizer to convert text to voice format. Step 5, voice is generated. The desired form is obtained in step 5. Step 6, stop. Now we shall move on to the second module of the project, image to voice. Here we have some sequence of steps to be followed so that image is converted into voice. Step 1, start. Step 2, choose option 2 to convert image to voice. Step 3, call the function image to voice. In step 3, we are calling the function which converts image to voice. Step 4, capture the required image. In step 4, we are making the use of camera to capture the required image. Step 5, convert image to text using teaser at OCR. Step 6, split the text into paragraph. In step 6, text is splitted into paragraph. Step 7, text is displayed on the screen. Step 8, call text to voice function. In step 8, we are calling the function that converts the text into voice format. Step 9, convert the text to voice using eSpeaker synthesizer. In step 9, we are making the use of eSpeaker synthesizer to convert the text to voice. Step 10, voice is generated. In step 10, the desired form is obtained. Step 11, stop. Now we shall move on to the next module of the project, gesture to voice. Here we have some sequence of steps to be followed to convert a gesture to voice. Step 1, start. Step 2, choose the option 3 to convert gesture to text. Step 3, capture and read the gesture. Step 4, crop the useful portion. Step 5, convert RGB image to grayscale. In step 5, we are converting RGB image to grayscale. Step 6, blur the image using Gaussian blur algorithm. In step 6, we are blurring the image using Gaussian blur algorithm. Now we shall move on to the next module of the project, voice to text. Here voice is converted into text. Step 1, start. Step 2, choose the option 4 for voice to text conversion. Step 3, call the function voice to text. In step 3, we are calling the function that converts voice into text format. Step 4, open Chromium browser and connect to the website speechtexture.com. In step 4, we are making the use of Chromium browser and speechtexture.com. Step 5, select any universal language. In step 5, we can choose any universal language. Step 6, speak now by turning on microphone. Step 7, check if the voice is perfect. Clear the screen. The text is displayed. In step 7, we are going to check whether the voice is perfect or not. Later, we are going to clear the screen and the text is displayed. Step 8, recognize it as error and resend the voice. Go to step 4. If any error is recognized in step 8, once again we need to send the voice. So that again we need to go back to step 4. Step 9, execute the above steps recursively until correct output is obtained. Step 10, stop.
As the figure shows, gesture to voice recognition. What do you mean by gesture? Gesture is a movement of body parts in which visible bodily actions communicate particularly through messages. Gesture, it can be includes movements of hands, face or other body parts. The figure shows the gesture is captured and the useful portion is cropped. What we are seeing, a red color point in the figure, it is an gesture that is captured and it is converted to RGB image as shown in the figure 1, and the gesture is converted to text that is shown hard, bright, fast in the figure 1. In the figure 2 shows the gesture capture is not recognized, so it is showing others in the figure 2. Let us move on to the other diagram, that is image text to voice conversion for blind persons. The image will be captured by Logitech camera using eSpeak synthesizer text and it is converted to speech. So the figure shows it is captured the image by Logitech camera and it will give a speech. See, the downward blue line says image is captured and it is said as Raspberry Pi 3. And next diagram, it says speech texture. What we have described in the following modules, speech texture is nothing but it is an online multi-language speech recognizer that can help we to understand long documents, books, reports, blogs with your voice. Okay. The speech is going to convert. In the first figure shows user wants to give voice as input and get text as output. He or she can open Chromium browser and website name as speechtexter.com as shown in figure 1. And speech texter takes the input from user and gives output in the form of text as shown in figure 2. This is the output what we are seeing in the image. There are 100 languages in this speech texter. Speech texter is nothing but it is an online multi-language speech recognizer that can help we to understand long documents, books, reports, blog posts with our own voice. Next, this is a model. We have designed the prototype model for blind, deaf and dumb people by employing a single compact device. So, this is a Raspberry Pi and here webcam is connected to one of the USB port and speaker, this is a speaker, is connected to pin to give the voice output. So webcam will read the content and it will send to Raspberry Pi and Raspberry Pi which in turn activates the speaker to give voice output. The remaining part of the project will continue my project co-mate. Thank you.
This is Nandini. Next slide is conclusion. This project aims to lower the communication gap between the deaf or mute community and the normal world, help them to lead standard lifestyle. This device is used to convert text or image to voice for blind, speech to conversion for deaf and conversion of hand gestures to text for dumb people. We have designed the prototype model for blind, deaf and dumb people into single compact device. The advantages of this device, it can be easily carried due to less weight and size. The device can be used as smart assistant for differently abled people to communicate with others, and it is language independent system. Then next slide is reference. Chukai Y, student member IEEE. Anli Tain, senior member and Arise RDT. Portable camera based assistive text and product label reading from handheld objects for blind persons. 2013 IEEE. Fernando Ramras Garbay, Cesar Milan Oliveira, my Hawks device for the communication between blind deaf, deaf blind and unipaired 2014. Thank you.